Hello everyone, welcome to the Geoecolologist. I am Dr. Krishnanand and you have been watching my videos on various aspects of geography on my channel. So in today's session on climatology, we are going to discuss about one of the very interesting phenomena that happens in Earth's atmosphere, that is about jet streams. So what is this jet stream all about? Why is it called so? What are the factors associated with jet streams formation and how it was discovered? All the important aspects are going to be covered in this session. But before we go ahead, don't forget to subscribe to our channel and also share the videos with others as well. So now, let's understand the concept of geostrophic wind first before actually going to the concept of jet stream. So what is this geostrophic wind? The word geo basically means earth and the Greek word strophy is for turning. So if you look into this graph, what do you see? This is the starting point and this is the high pressure here. Right? So it's 920 millibar, and what is happening from high pressure, it is going towards low pressure. That is the normal wind action, as we have learned in the previous sessions as well. So what do you see here? This wind is not going straight, rather than what is happening to this, it is turning here, right, as we are going from high to the low pressure. So what is this turn? This turn is basically the turn with this Coriolis effect, the Coriolis force, the force because of the rotation of the earth, right? So across the pressure gradient, when this Coriolis force also has an impact, there is this turn in the wind. So this is what we say is this geostrophic wind, which keeps on turning. So here the velocity and the direction of the wind are important, and they are the net result of what? The wind generating forces. So what are the wind generating forces? Remember, the pressure gradient is the most important factor, which is actually led by the temperature gradient. Remember, so temperature gradient, pressure gradient, and the Coriolis force. So now remember one thing, that an air parcel initially at rest, okay, will move from high pressure to low pressure, as in this case we see, right? Because of what? Because of this pressure gradient force, which say PGF. And when it moves like this, there is an impact of Coriolis force, because of which they turn as well. And that is where the turning factor leads to this creation of something which is geostrophic wind. So further what we see is that geostrophic wind, it is basically deflected by the Coriolis force to the right in northern hemisphere. So remember, it is deflected towards right in northern hemisphere. So if you look into the northern hemisphere, this is the straight direction and this is the deflection. So this is right in the northern hemisphere, and what happens? Left in the southern hemisphere, right? So this is the normal rule. Then as the wind gains speed, now we are talking about when it is actually gaining speed, the deflection increases. Now this rate of increase in velocity, which also leads to the rate of change of this strophy, which is change in the deflection, until the Coriolis force is equal to the pressure gradient force. Now remember, when this Coriolis force, the force because of rotation, is equivalent to this pressure gradient PGF, then in that case, what will happen? Remember, at this point, the wind starts to blow parallel to the isobars. Remember, perpendicular to the pressure gradient and parallel to the isobars. So remember, if isobars are like this, it will start blowing parallel to the isobars. So this is that kind of wind which is called a geostrophic wind. So if this is a question somewhere in multiple choice, that which of the following wind blows parallel to isobars, it basically means here the force, which is Coriolis force, is equivalent to the pressure gradient force, right? So pressure gradient force acts across these pressure belts and the rotation force is across this. So remember, rotation force is almost cutting across this pressure gradient force, and when these become parallel, it means it is so much of turn involved that it becomes parallel to this. So that is where this geostrophic wind is formed. So how is it related to jet stream? It is related to jet stream because jet stream itself is a geostrophic wind. So jet stream is the best example for what we say is geostrophic wind, that blows horizontally through the upper layers of the troposphere, generally from west to east. Now here is a significant catch here. This is the general direction. It means it's not universal, it's not entirely on the planet, but general case it is going from west to east as the earth rotates. So that is important. And remember, the height here is 20,000 to 50,000 feet. That is about 5 to 9 miles above the Earth's surface. So jet streams develop where the air masses of differing temperatures meet. Now this is another point here. So we are going to elaborate further on the formation of jet stream. So now from the concept of geostrophic wind, let's go to the concept of jet stream and understand it in details. So what is a jet stream? A jet stream is a geostrophic wind that we have learned, and it is blowing horizontally. Now remember, this is saying it is blowing horizontally through upper layers of the troposphere, right? So altitude is about 20,000 to 50,000 feet. If you say in miles, what you see here, this is 5 to 9 miles, and this is upper segment of the troposphere. And remember, if you see this flight here, that is why it is called jet stream, because of the jet layer where jet planes fly. And stream is basically coming from what? From the fluvial process. Remember the fluvial landforms, it is flowing. So stream is something that flows. It basically means what? This jet is one characteristic and stream is other characteristic. Stream is just like a river flows, it meanders, right? Similarly, this wind also flows, which has a meandering action as well. So similarly, like a stream, there is this stream of air, and that is called jet stream, which is very high speed. So it is a jet layer thing. So normally in this layer, what happens? The aeroplanes also get flight effect, because if they are moving in the jet stream direction, they require less time to reach their destination, and if they are opposing the jet stream and they are going somewhere else, then they require more time. So this is another example. So this is also called jet layer because of that, and jet stream is the basically this particular layer of this atmosphere, troposphere, which is largely flowing like a stream, which has a meandering nature. It keeps on flowing like a waveform, right? And it is almost lengthy up to how much? From 1600 to about 3200 kilometers of the length profile, right? And general direction is what? It is west to east. So these are certain basic points that is needed to be kept in mind while discussing about jet stream. Now let's elaborate further. So what we see here is this, that jet streams develop where air masses of differing temperatures meet. Now if you go back to the concept of the pressure gradients on Earth, remember we had learned about the tricellular model, the Hadley cell, the Ferrel cell and the polar cell. So what happens? Remember, the height of the troposphere is maximum in the Hadley cell region and minimum in the polar region, right? From 8 to 20 kilometers almost it varies. And what happens gradually? There is a zone where you have transition. It means the air masses have different kinds of nature. So for example, what is the difference? Now here the wind rises, and what happens in subtropical belt? It subsides. Now the other wind is coming from this side, which is from subpolar front, which is a low pressure belt, right? So remember what happens? The wind from the subpolar low rises up. It goes to the subtropical high. The wind from the equatorial belt also goes here, and they both subside here together. So here what you see is the wind coming from the polar front region, that is the subpolar low, and the wind coming from the equatorial region has different characteristic. It means it is cooler and it is warmer in nature. So what happens? There is this subtropical high pressure belt where at this position, when this warm meets cool, so what happens? Remember, they cannot intermingle completely. So what happens? In between there is this air mass which is trapped, which is like a void, which is like a vacuum created. So where this air mass is trapped, that is the source point, that is the origin point of a jet stream, right? Where with turning and further enhancement in the speed, it creates a jet stream. So one region where you have this meeting point is the subtropical high pressure region, and then the other is similarly where, remember, the polar front. Here also what happens? This wind from subtropical high goes to this, and the wind from the polar high also goes to this, right? So here also there is mixing of two kinds of wind. So this is going to be the second belt where you have this jet stream formation. Why? Because look here, this is the condition, the stream, as I said, right? The meander that is created. Remember, this is polar region which is cold, and the other regions, that is subtropical and tropical region, which is warmer. So when they meet, in between they form this layer of this fast wind which is blowing from west to east generally. So this is called a jet stream. So usually what happens? The surface temperatures determine whether the jet stream will form or not. So that is important to remember. So if you have not understood the concept of these tricellular model, please go to the playlist and watch this as well, that how Hadley cell, Ferrel cell, polar cell functions, because it is the key factor in order to understanding the formation of these jet stream. So that is important here. So remember what is important here? The greater the difference in temperature. Now remember, if warm and cold are extreme, more is the velocity, because remember the cold wind goes inside and the warm wind goes up. So this rate of going up and down and creating this circulation becomes more vibrant, becomes more aggressive in nature because of this difference, right? So it creates a velocity that is important for becoming a jet stream because of this gradient, very steep gradient or sharp gradient from warm to cold. It means the wind is going to be very fast. So that is important. So jet streams extend from 20 degrees latitude to the poles in both hemisphere. That is important here. So roughly what you see is the subtropical region and the polar front region. Polar front basically means where this polar high pressure belt and the winds from subtropical high pressure belt meets at this particular low pressure. So one is at the high pressure, one is at the low pressure. So this is largely a high pressure region where the winds meet, that is near subtropical high. So this is subtropical jet stream, and this is the polar front jet stream. So these are the two major jet streams that is there. But remember, these are not the only types of jet stream on the earth. There are certain localized jet streams as well, which we are going to learn further more. So a little more on the details of the origin of jet stream as we have understood. So look at this image. Number A, B, C, D. What is this? These are the steps. So this is step 1, step 2, step 3 and step 4. So what is this stepwise analysis of the formation of jet stream? What is happening here? Initially, what is happening? There is a mixing, right? You see this? So mixing of the warm and cold air here is happening, right? Then gradually it is picking up speed. So remember, in this situation, what you see, if you know about the function called sinuosity, remember we have learnt about sinuosity in the channel morphology lecture. So if you have not watched channel morphology lecture, do watch it. But remember, this is talking about air and we are talking about channel morphology. Why? Because it is the same stream character. Here it is largely a straight nature when its velocity is still picking up. It is just the first stage where warm air is mixing with the cold air. Gradually what happens? As it gets more energetic, remember, this meandering starts to develop. So look at this one, the third one, where the meandering has now matured. What is happening? Now this fluctuation is happening here, right? So this is a horizontal motion, but with Rossby waves, as we know. Here this wave action, this is what we say is Rossby waves, remember? So near the polar areas, what is happening? This wave action is being created and gradually it is intensifying, right? Because of this steep gradient, and gradually when it has lots of more energy, what you see here, remember what happens in meander? There is a formation of oxbow lake, right? It is left out and it is said oxbow lake. Similarly here, what happens? Too much of meandering happens and then these join together and from here they get straight and this is left as the centers of low pressures and some high pressures, and these create these storms, remember, like cyclonic and anticyclonic storms as well. So that is important to remember in these 4 steps, that this is the way this jet stream functions. So in 4 steps, by drawing this diagram, you can learn it. The first step is the mixing of the warm air and cold air. Gradually the energy gets higher and higher, remember, and these meanders become very fast as well as very huge, and gradually they again develop these pressures, belts of these localized low pressure and high pressure, and they again go back to the first one, the straight one, and this keeps happening around the polar front region and the subtropical region. So what we find out is this origin of jet streams is triggered by these 3 factors. What is that? First is the thermal gradient, that is the heat portion, right, between pole and equator. So what we have is that polar area is cold, so it has colder winds, and warmer winds are there in these tropics. So when they collaborate, they form these jet streams. That is the first thing, that is the thermal gradient part. Then what we have is accordingly pressure gradient. Remember, pressure gradient is equally important. From high pressure to low pressure is the function, right? So that is also existing. So one is the temperature, that is thermal part, other is the pressure, and the third and most important is what? The Coriolis force, as we know, right? So that is why it is important. So pressure gradient between the surface and subsurface air over the poles is also equally important. It means not this horizontal only, but also this vertical air mixing is also important, and the Coriolis force, that is important. So as a fourth factor, which is because the west to east is the direction of these winds in a larger framework. So these are the factors and these are the processes, and this is the way it operates. So I hope you have understood about this from A to B to C to D, how it changes. So this is about the concept of origin of the jet stream. And now let's talk about how did we know this, the discovery of jet stream. So during Second World War, what happened? There was this bombing mission where American fighter jets were actually going to where? To Japan on the mission of bombing. And what happened? When they were going, they encountered this high speed cirrus cloud and the wind there at almost this altitude, that is about 6,000 meters. So this time during Second World War, technology was such developed that they could actually clarify this, because in earlier 1904 as well, these high velocity winds were actually discovered in higher troposphere. So they called it jet stream because this was the layer where the jets fly, right? Also because of one reason, that they had drew analogy of this water jet. Remember the spray, water spray or water jet, how fast it is? So similarly like that, this jet speed is also there, high velocity is also there in the jet streams. So stream is water and jet is because of the velocity. So this was the nomenclature given to it using the analogy of water jets. And now coming to the types of these jet streams. So what are the various types? Remember, based on the locations on the earth, we have two major parts first. So these are the major or the planetary scale of jet stream, which are polar front and subtropical westerly. This we have already discussed because of these particular frontogenesis, frontal action, cold and warm front. So polar front, we have this polar front jet stream, which is at the subpolar low pressure belt, right? And subtropical westerly jet stream, which is at the subtropical high pressure belt. So this is called the subtropical high pressure jet stream. Now apart from these, there are three more jet streams that we need to learn, which is part of the localized situations in particular areas of the world. So what are those? Tropical easterly jet stream. So you see this, the word itself is tropical, so its origin is also in the tropics only. Then we have polar night jet stream. Remember the fluctuation of the upper temperature in poles and the lower ground surface in the poles? That also leads to this kind of polar night jet stream creation, specifically in the winter times. And then cross equatorial jet stream, which is very much interesting, which is also called Somali jet stream and very famously important for the southwest monsoon. So when we discuss about monsoon, we also talk about this kind of jet stream, which is there, also named by Somali jet stream, which leads to actually push these trade winds in the opposite direction, which brings the southwest monsoon. So these are the jet streams, various types on the basis of location. Now let's one by one understand their nature and their characteristic. So the first one that we see is right from the pole part. What is this? Polar front jet stream. Now this is the polar jet. Can you see this and how it is meandering like a stream? So this particular jet stream is what? It was discovered by Rossby. Right? Now remember the Rossby waves, this wave that is created on this particular subpolar low pressure belt because of this Coriolis force as well and the pressure gradient. So this is called the primary jet stream, right? And then it has an average speed of 215 km per hour. So huge speed. And in some cases, the speed also goes further, double as well. So the length of this is about 1600 to 3200 km, and depth, that is talking about the vertical expanse, it is about 1 to 2 kilometers. So this is the basic nature of the polar front jet stream. Now let's talk about the next one. That is the subtropical westerly jet stream. So what is this? They originate at the meeting point of Hadley cell and Ferrel cell, as we know. And remember, on account of permanency of this Hadley cell, this jet stream remains almost intense throughout the year. Because remember, the Hadley cell and this Ferrel cell have a permanent nature, and that's why this jet stream has a permanent nature throughout the year. That is from west to east. And although with shifting of the pressure belt, its path also shifts. Remember, because of this sun moving north and south, vertical going on the Cancer and Capricorn. So what happens? There is a shift in the change in temperature belts as well and the pressure belts as well. So it keeps fluctuating north and south according to the pressure belt fluctuation as well, but their direction is west to east only, and their intensity is maintained throughout the year, because throughout the year there is a mixing of warm air from the equatorial side and cold air from the polar side. So that is its nature. Let's talk about the third one, which is important for Indian subcontinent, southwest monsoon. Remember the tropical easterly jet stream? So what is its formation? Remember, it is located at an altitude of about 10 to 12 kilometers above our Gangetic plain, now North India, this section, and about 25-degree north latitude. So this is the area where it is there. And remember, it is called easterly. It's not west to east now. It is coming from east to west. Why is it so? It's a very interesting concept. Now let's understand this, that what happens here in the summer, during the summer what happens, there is this low pressure belt created here, right? Low pressure belt is created in the Tibet because it warms up, right? Sun is shining here vertically overhead on the tropics, Tropic of Cancer. So what happens? This area receives lots of insolation, and remember, is a barren area. Here low pressure belt is created, and when low pressure is created, it means basically what? The wind rises up, right? Hot air rises up, and when it rises up, what is the scene? It mixes with the west to east, the westerly jet stream, remember, which we have learned, right? So subtropical westerly jet stream is flowing like this, and it mixes with this, right? So when it mixes with this, there is a whirl action created, and this whirl action, that is the low pressure air mixing with this, now creates what? This action, and due to this action, the direction is now reversed. Now this is the direction of these high speed winds, which is tropical easterly. So what you observe here is that going on a particular altitude, that is about 10 to 12 kilometers above the earth. Now here, because the wind is coming here, right? And remember, this is not a straight line wind. It is like this, and this is moving up the wind from here. So it catches it, and it again, remember, it is the northern hemisphere. So with the Coriolis force, what will be the deflection? If this meets this, deflection is towards right. It basically means east to west. So from east to west, it starts flowing with a high speed, and gradually it comes here in the Indian Ocean and again subsides down, and it pushes these air to actually go towards India. So this is what the action starts happening. It means the air here, that is high pressure, is here, low pressure is here. So when this wind is creating this high pressure, it is pushing the downwind to go here, and that is where southwest monsoon is there. So this is the entire mechanism of this tropical easterly jet stream. It goes like this and subsides here again, and when it subsides, it is a high pressure, and then from high pressure again, the southwest direction of the wind starts going towards the continent, and that is where this is southwest monsoon. So this is how it is created. The winds come from here, they join the westerlies, they change the direction, right? Westerly is going on, and here is the creation of tropical easterly jet stream. So it originates due to what now? Excessive heating of Tibetan plateau. That is the most important reason here, right? And it has a relationship with what? Oscillation and shifting of ITCZ. Now remember, this is the zone, equatorial zone, where you have ITCZ, and ITCZ keeps shifting up and down depending upon the sun, right? When sun is vertical on the Cancer, it goes up this side. So that's why with shifting ITCZ, it has a relationship, right? And its arrival heralds the onset of southwest monsoon. So when this tropical easterly comes here and creates this high pressure here, it means now the wind is getting pushed towards Indian Ocean, towards the particular belt of these western Ghats of India, and that is how the southwest monsoon is triggered. In details, again we discussed this when we are talking about the monsoon. So now let's look into this video created by NASA about these jet streams, how they operate, how they move, how they meander. So let's understand this through this particular video. So let's see this. So this is a video which shows us the polar area first. So can you have a look here? What is happening in the polar region? The warming and the cooling air is mixed, so there is a polar front jet stream which is gradually gaining strength. It is meandering fastly. It is gaining strength and strength and strength. So larger meanders belts, you can see how the fluctuation happens. And now you see the Indian subcontinent where the westerly actually catches up this hot air, and gradually you see the change in direction now. So this change in direction is what is the tropical easterly, and it starts blowing from east and again pushes the monsoon wind. And if you can see the timeline, it is July. So this is when the monsoon is there in India. So June and July timeline. So this is how you can look at this video. You can pause the video, you can play it again. That looking at the timeline in the left corner of your screen, just look at what is happening to this entire jet stream. So this is important to understand or visualize this concept what we have learned right now. Now let's understand the polar night jet stream, which is basically created about how much? 40 to 50 kilometer of altitude, which is at the polar region, right? And this is important. Why? Because it's talking about polar night. Remember, it's almost at 6 months there is a winter night at poles. No sunlight is received. So what happens here? There is extreme cooling on the ground, right? And in the upper atmosphere, remember what is there? Ozone layer is there. So it has kind of a UV protection shield, and also it has higher temperature in comparison to the ground. So there is this fluctuation here, right? There is a change here of temperature. So this kind of jet stream which is formed here is called polar night jet stream, right? Because of this altitudinal variation. Now this is a vertical kind of jet stream that you see. So they are called polar night as they are formed during extreme long winter nights, that is about 6 months at the poles. So it is found due to the thermal contrast between subpolar layers and polar layers, and becomes westerly due to the Coriolis force. So remember, there is a thermal contrast. Already we know this polar area, subpolar area, there is a thermal contrast, and also the ground factor is important here. So this is not normal meander, but this is also about this altitudinal factor which is here, right? So that is both impacts here in the formation of polar night jet stream. And at last, let's talk about this cross equatorial jet stream, or also called Somali jet stream, that we discussed. Now remember, this is a particular jet stream which is found here near the Somalia, right, in Africa. So this is where it starts blowing from, what you see is west towards this direction, that is northeast. So southwest to northeast is its direction. And what happens when the sun is going this side towards the Cancer, the ITCZ is shifting. So what happens? These winds are actually pulled away and going into the other hemisphere. So what you see in January, this is the fair direction that you see south of India, right? What is happening in July? The belts are shifting up. So what has happened? This particular place where there was the mixing, right? In ITCZ, the air coming from both the direction, now it rises up and it goes from west to east towards India, and then that is how at 3 to 4 kilometers above the surface it is now actually forming. So what happens here? It is formed due to unequal heating of the continent of Africa. Now remember, again the thermal contrast is happening between the ocean and the land, right? So this is actually heating faster. So what is happening? The wind is rushing here. And when wind is rushing here, the ITCZ is shifting and it is being pulled towards this direction. So what is happening here? The winds from the southern hemisphere are crossing here. That is why it is called cross equatorial jet stream, because the southeast trade winds are actually pulled to the northern hemisphere. And that is where this upper air circulation, this zone of mixing, it is created. And that is where this is called Somali jet stream, which picks this wind and it takes it to the Indian continent, and that is why it is important for the southwest monsoon. So it crosses the equator and becomes southwesterly in direction due to, again remember, the cross equatorial position is important because of this ITCZ as well as Coriolis force. So it deflects towards right here, right? So that is what happens to this. So Coriolis force also here, and then it leads to what? It leads to this intensification of these monsoon winds. Remember, monsoon winds are already here in this particular direction because of the tropical easterly jet, and it is now further aggravated by this Somalian jet stream. So this is why the monsoon intensifies on the basis of these two jet streams that we have learned. So in details, when we learn in the monsoon, there also we are going to discuss the impact of these jet streams. So now, when we have learned the details of jet stream and its various characteristics, its various types, in the sessions to come, we are going to learn about one of the most awaited topics in climatology, that is the monsoons. So stay tuned, stay safe, keep watching.